Okay, I've been buying some voltage regulators. I bought the Castle Creations battery eliminators, BECS, which are these things. That's the BECS II, the CC BECS II, and that's the BECS I, or they just, yeah, it's just the BECS. That's a 14 amp, and this is 10 amp, or up to 10 amps. These are basically voltage regulators. Now, I'd heard about these. Dave Cochran from Cochran Robotics, I think it is, mentioned them on one of his mails, that he was putting them in his InMoov, so I had a look into them because I've been looking to get some voltage regulators, because I was using just these cheap ones just to drop some voltage down just on the amplifier, but not to actually power servos or anything. So these are, as I say, that's a 14 amp, there's a 10 amp, so these are very powerful units. These aren't voltage increasers. You can't actually get more power out of them. They'll just take in a voltage and drop it down, or fix it at a certain voltage. But these are switching ones, so they're very efficient. So there's not a resistor in them. They're it's not that, it's these. They just turn the current on and off, or the voltage on and off, very quickly to control the voltage. So you can program these, so any voltage up to, I think, about 25-30 volts in, and I'll show you the other one. This is how they basically come. This is the 10 amp one, so that's got 2-wire input and a standard 3-wire output. You need the 3 wires to program it, which we'll look at in a second, and that's his input. But this one is probably slightly easier to understand. It doesn't come with the connectors. I've just soldered them on. So that's the volts in, and you've got 2 cables. This cable used to have a plug on it. I've just cut it off and put the output connector on it, which I'll be connecting into my other unit. So these are the XT60s. The way these work is, we're not using them in a model radio control system. Normally that would be plugging into a radio controller, and this will be supplying the voltage out. Or there's volts on both of those, but the way we're going to use this is going to be the output voltage. That's the input voltage. In this case, I've bought myself a new 12-volt power supply. I was running off 5 volts before, but it wasn't enough because I wanted to run 6 volts on some of the system. So I'm now going to be putting 12 volts in that end, and I can program this for a 5, 6, 7 volt or whatever output, and it's a fixed output as well, so it's actually regulated. So if the input voltage varies, the output voltage is going to stay solid, as long as that input voltage doesn't drop below the output voltage. So I thought I'd just show you how to program these up as well. So I'll just turn my computer on again. I'm just waiting for the computer to start up. With these ones, because you don't have the second plug, you'd need ideally to have an adapter on there, because you want to keep that 3-pin on there to be able to program it. We're not obviously using the signal wire, so we'd just be using the output, which would be the brown and the blue. Brown being a neg in this, brown and red, brown being ground and the red being positive in this case. Orange would be signal, but we're not involved in any of that. The orange signal input is going to be used to program them. Now, to program these up, so you can set the voltage, because I think they come at about 5 volts as a default. It says in the packaging, but I don't want to be running them that. You get a little, or you buy a little Castle Link V3 programmer, which is a USB device, and that will just plug into that cable there. If you were using these ones, you'd just be plugging it into that 3-pin. So we're not going to put any volts on at the moment. On the if you go online, you can download the Castle Link software. Now I've got it on my laptop, so I'm just going to pan up so you can see it. Oh, not on the laptop, on the computer. There's the Castle Link software running there, which I think you can see, which you can, yeah. It's saying USB not connected, device not connected. If I just plug in the USB into the computer, it should recognize it. And we've got connection USB connected, device linked, so it's actually now seeing this device. We've got a green light on there, and we've got a little red light on that device there. If we go into basic, you can see we've got a selectable output voltage. It's on 6 volts there at the moment. You've got 4.7, 5, 5.2, 5.5, 6, 8, 10, 12 maximum. And then you've got custom. And you can actually... And you can see it comes up with if you want above 6 volts, which we can do. So we can go up to 8 or whatever. But we don't really want to, because we're going to use the standard output voltages, which are the default 5.25 and the minimum 4.7. I'm going to set I'm going to start running my InMoov at the 5.25 and 6 volts. So if we just try 6 volts for the second, just to show how this will work, we can update that. Update setting completed. Just to show you, we've now got because we're running off USB, we're actually got a 5 volt rail on there, or approximately 5 volts I think it is. So it's actually got some voltage going into it, which we should be able to measure. But this isn't obviously enough to drive a motor, but it will just be the voltage of the yeah, it's 4.7 volts in there, 4.6, 4.7. You can probably see that on both of these outputs. Sorry, that's on the input there, so it's actually seeing that voltage there. On the output, 4.4, yeah. Something to be aware of, because that's actually the input, and we've got the USB connected. There is, as I say, volts on there, so you don't want to have the USB connected. Yeah, there is voltage on there. You don't want to have the USB connected at the same time as your source, your power pack. Okay, so we've now programmed. Let me take this device out. We've now programmed the BEC for 6 volts. So on this connector, I've got my power supply running, which I'm running at 10.5 volts. We should just prove that. Just see that. Yeah, 10.5. Let's pretend we're on 12, because that's what I'm going to be running at. It doesn't really make any difference. So there's 12, something like that, up to about 12. So this is just running off my bench power supply at the moment. There's very little current in there. But so we've got an input coming in on that of 12 volts at the moment. So if we plug that into the input of the BEC, got a light back on it again. This is now programmed to be 6 volts. So we're not using that cable at all, because we're just going to, in these particular devices, we're just going to use that as a control. But that should have 6 volts on the output. .961, so it's near as anything, which is controlled. So as I turn up or down, well, as I turn up the voltage on my power supply to this, that should basically stay the same. So in other words, the input can vary a little bit, but the out should be fixed. You can't see it, but I am actually turning up the output. I can actually show you that somehow, but I won't do that for a minute. To 12 volts, 16, 17, 18 volt input I've got going on at the moment into this, and I've still got the 6 volt output, just to show that is true. If I do it across the inputs, there you go, 18 volts on the on my meter there. So I'll just hold it down properly. There you go, 18 volt DC input. So you've got 18 volts going in, and on our programmed output of 6 volts. To easily change that, again, it's very simple to program, so they're rather neat little devices. As I say, we just go back online with that device. On here you've got a ground and a well, just a ground pin, as long as you get the ground pin the right way around. We've got green connection. I'll just pan you back up to the screen. We're connected, green light's on. If we go back into that basic, let's just take that up to 12 volts and it's going to give us the warning. So we're now going to try and run that at 12 volts. Status update, okay, right. Just pan you back down. If I disconnect that bit, which I should have been earlier, it's not going to knock us offline on the USB connection, so it's probably the best way to do it. But it goes red to show it hasn't got a device on it. So we should now, we've got 18 volts input, we did a second ago. Let's just make sure we still have. Yep, you've got 18 volts coming in. Got the light on again, so if it all goes to plan, we should have 12 volt output on that. .87, so it's not bad. Without a load, it'll go up a little bit if we put that under load probably. So that's working fine. We'll just drop that down because I don't want it to be sitting at 18 volts, 12 volts. Okay, I thought I'd show you these little cards that I've been making up for the power distribution and control distribution for the InMoov. They're just little PCBs. I've got a little voltage display, which are only a couple of pounds on Amazon, I think they were, or eBay. An XTC connector input. I've got a the ribbon cable which was used on the Gales version of it. I've just, because I had all these connectors, I've just retained that for connection. I was looking at using a Cat5, then I was looking at USB cable, which a lot of other people have got, but I've got all those connectors, so I've just reused them. I put in some fuses, which these are 1.5 amp resettable fuses from CPC. You can buy them from RS or Maplins and places, but those are the ones I've used, just so they'll trip out. So hopefully, the idea being it will save my motors if anything happens. We'll see if that is the case. What these are doing is the signal and ground is coming in on these pins, but not the power. Power's coming in here, so it's separated, but the ground and the ground, the ground rail of the power and the ground of the signal is connected together. Otherwise, you're not going to get the motors to work, to rotate in the right direction. So on the outputs, the white wire is being picked up off the pins here, the black wire is being picked off the pins here, but the red wire is coming from the input voltage. So we don't need to power from the EZB, it's not supplying power. So I can put a different voltage into that connector and control my device. So if I show you, plug my meter back up again. We've got 6 volts on that. I've set this to be 6 volts. It's got a 18 volt input at the moment, which I'll turn down because we're not going to run at 18. But I have got a 12 volt power supply, so anyway, we're running at 12 and a bit. But this is still set at 6 volts. So if I plug that into there, it's just displaying what my voltage input is, which is, I found quite useful. So you can remember, rather than just color coding, which a lot of people are doing, which is very sensible. So you know, they have one color for different voltages. I can actually see what the voltage is going out there. So that is the voltage that will go to the servo, and you can just see it on the meter there as well, just to show that both the meters are remarkably accurate. These, for £1.50, they're pretty good little voltmeters. So that voltmeter is just paralleled off the two hot and the cold of there. Underneath there, may look a touch messy, but I've just taken the signal wires, go straight through to the white wire, which are those purple wires. The red wires I've taken through these, move them around. these resettable fuses. And I've also, as you can just see in the middle there, I've got an LED. The LEDs are reversed, so if the forward voltage, the LED is not going to go on. If these go open circuit, the LED will go on. So in other words, I can see if one of the fuses is tripped, because I'll get an LED indication. Just to show you that, let me just pull out. I'm going to need a load on it. Hold on. What I'll do is just put that back in again. Let's actually put a load on there. It's got a servo on it. There, you can see the LED has gone on. The reason it didn't go on because there wasn't a circuit going on. So in other words, by putting in the servo, the positive rail is the plus volts is going through the servo and back onto the ground rail, hence lighting the LED. Otherwise, if you take your load off, it's open circuit, so it's still not going to light the LED. So that's the effect of the fuse popping effectively, but as I say, they're resettable, so once they cool down, they'll come back on again. So all the LEDs are doing is just giving me an indication that one of these resettables has gone into trip mode. Otherwise you wonder why motor's not working. You may have burnt out something or done some damage. So that is those devices, and they're getting slightly warm, but hardly noticeable. Very cool. Right, the other device, that's only got the single connector on it. I haven't wired it up yet anyway, but we can see how to program it. Let's just make sure we don't short out the outputs. Put a bit of tape on them. Well, if I pan up to the screen again, we can now see that's connected, USB connected. Let's just bring you around so you can see that screen a bit better. The lights are on. Go back into the basics. It's set for 5.1 volts, which is what I'm going to leave it on. You do have a we're on auto on there. It's not a custom range, it's just giving you all of those. So it's slightly different on these Castle Links. This is the Castle Link 10 amp, so this is the original Castle Link. So the display is slightly different than the more powerful one. So you've got direct control. It goes up to 9 volts. The other one went up to 12 volts. It's got an asterisk against the default. I'm going to leave them at 5 or 5.1 because I'm going to run these cheaper units, not cheaper, these smaller units are going to be for, let's pan down again. These smaller BECS I'm going to use for the hands. So the larger BECS I'm going to use for the shoulders, the 3 servos in the shoulder on each side, so one that'll be left arm, right, and one for the right arm, and another one for the torso rotate tilt. I'm going to do off these larger ones. These couple of 10 amp ones, which is more than enough anyway. 10 amp ones I'm going to do the hands with, so one per hand, and another one probably I'm going to put on in the head, and drop that down to 5, keep it at 5 volts for the jaw and the eye servo. So that's the BECS, which are, and these are quite expensive. They're not particularly cheap. They're about £20 each, so it's a bit of an investment, these things. Okay, I just want to test out these smaller voltage reducers. I was using one of these in the head to supply voltage to the amplifier, to drop down from 5 volts to whatever it was for the amp required. I just want to see if these vary depending on input voltage, but at the moment I'm running, let's see what input, I've got no voltage available on the input at the moment. Let's just prove that. Right, that's no voltage there, which is right because I'm not running any. I'll just bring that up to, I'm running at 10 volts off my bench power supply, so I'm seeing 10 volts on there. I can turn this up or down. Yes, it's going down. So that's dropped down to, so just take that down to 5 volts. Five-ish, near enough. If I turn my input voltage up, that's good. That's gonna keep it at that 5 volts. So that is controlling the regulation of that. So it's fixing it at that voltage. That's sitting at 9, but you can't see the other meter. But I've got a 7 volt input to it, 5 volts. If I go below its output, it's going to drop down here. And if I go back up, that's 10 volt inputs, and it's fixed at its 5 volt output. 12, 13 volts, still fixed at 5. 15 volts, 16, 17, 18, and that's still holding it at 5. So that is properly regulated. But it's obviously not going to supply the current. As I say, these are going to be my little boards that will be driving the servos, which and I've got them configured as effectively circuit 1, 2, 3, 4, 5, 6 on there. I was thinking of fixing these underneath there, but I'm actually going to mount these in a box just next to these units, so that is going to be the cable. It should really be ideally a bit fatter, but they're quite happy at running up to whatever current I'm going to draw off that cable, so we'll keep it at that. It's only a short little run. The input runs from the power supply are going to be even fatter than these. It's going to be this sort of thickness cable. That's what I'm running as my main power, which is about 1.5, at least 1 mil, 1.5 mil probably, around that sort of size. So okay, that's this for the moment. Go back to the Castle Link software, just so you know where to get it from. If you go to the Castle Creations website, it's on their download page, and it's the Castle Link software. The units, as I said, that I was using are these two devices I've been using. It's the BECS 10 amp and the BECS II, which is a 14 amp, and those are dollar prices, but they're not far out the pound prices. I think they're £18 and £25, so they're not cheap. They do a larger one, the 20 amp max, but I mean they're for I was thinking about maybe using them for the torso, but don't need that much power. These are more than adequate, these ones. I thought I'd recommend this website if you want to have a quick look at how BECS work. He does a really good little video on it, showing the linear and the switching different devices and why they're really, very good to use. He does some very, very entertaining little reviews. He's based in New Zealand, I think, so RC Models. Thumbs up to them, very funny.